Hello Ninja Warriors, welcome to yet another power packed session. And in today's session, as you can see that we are going to cover all the previous year questions from the chapter Quadratic Equations, and that too from January attempt, JEE Main 2024. So you can clearly see that in January there were 10 questions asked from quadratic equations alone. What does that mean? Because you always ask me, ma'am, what is the weightage of quadratic equation? So weightage of quadratic equation is nothing but you can see minimum one question, so you can definitely expect in your upcoming JEE Main 2025. And also I feel that the quadratic equation you should not at all skip, because again it is a foundation chapter. It is a prerequisite chapter for overall. You call it calculus, you call it sequence and series, you call it any chapter. Quadratic equation, a little bit here and there concepts will be there in upcoming chapters as well. So do not even think of skipping this chapter, because you see, okay, one question is there now, so let me just skip it. No, that's not the way. So this chapter you have to do for this one question, 4 marks, but for upcoming chapters as well, right? Okay. So let's start with the very first question. Let's see what kind of questions were asked in January attempt, okay? So here we can see that let S equals to this, okay? Then the number of elements in S is what we are looking for. So basically we need to solve this equation. And the moment I really see that there is root 3 plus root 2 involved, and root 3 minus root 2 is also involved. What is the relation between these two? Just tell me, what is the relation? So if you multiply these two, root 3 plus root 2, root 3 minus root 2, then what you're going to get is 1. Okay. What does that mean? If you multiply a square minus b square, so a plus b, a minus b is a square minus b square. So you'll get 1. Okay. Now, if product of two quantities, that means these two are reciprocal of each other, right? So now if I take root 3 plus root 2 as t, then automatically root 3 minus root 2 will become 1 upon t. Okay. So what I'm going to do is, and also if you take this power x as t, then this raised to power x will become 1 by t. So let's do this. Let's just get rid of this square root so that finally we can reduce it. So the overall equation will become t plus 1 by t equals to 10. Now just tell me, original equation solving, I know that this is a little bit tricky. It is not looking good also, but just tell me, I have just written down this equation. Just tell me one thing. Is it difficult to solve? What do you think? So this is t square plus 1 equals to 10t. T square minus 10t plus 1 equals to 0. Okay. All right. Now let us solve this. Let us solve this. T square minus 10t plus 1 equals to 0. So 10 plus minus square root of 100 minus 4 upon 2a. So 5 plus minus, this is 96. Root 96. Or you can just 25 minus 1, 24. Yeah, that's cool. T is equals to 5 plus minus. Now, root 24 is nothing but 6 4s are 24, right? So, 2 root 6. This is your, I will say, value of t. Now, understand one thing. What was t? What was t? So, t is root 3 plus root 2 raised to power x. Correct? It is either 5 plus 2 root 6 or 5 minus 2 root 6. Let us talk about this first. So, if I take x equals to 2 square, so root 3 plus root 2 square, let us calculate. Let's see what happens. So, clearly, it is 3 plus 2, 5 plus 2 root 6. Automatically, x equals to 2 is getting satisfied. Okay. All right. Now, what if I take x equals to minus 2? Then it is going to become 1 upon root 3 plus root 2 raised to power 2. That is going to be t, right? So let us solve it. So 1 upon it is going to be 5 plus 2 root 6. If we rationalize it, let us try to rationalize. Obviously, the denominator will again be 1, 5 minus 2 root 6. Okay. So we've got both the things. The moment I put to solve this, if you put x equals to 2, you will get this. If you put x equals to minus 2, you will get this. So there are two values, x equals to plus minus 2 are the two solutions of this equation, and here we go, two solutions. Option C is absolutely right for this question. Okay. And now let us move on to the next question, which says that alpha and beta be the roots of this quadratic. If P, Q and R be the consecutive terms of non-constant GP, okay, P, Q, R, consecutive terms of GP. Can I mark it as A, AR square, and rewrite the quadratic equation? Okay, so now my quadratic equation will be PQR, right? AX square plus ARX minus AR square equals to 0. Okay, and the roots of A is gone. A you can calculate, x square plus Rx minus R square equals to 0. Roots of the quadratic equation is alpha and beta. Okay, all right, alpha and beta. So now alpha and beta, sum of roots alpha plus beta is minus R, and product of root alpha beta will be minus R square. Correct or not? Yes. And now one information which is given to us. Let's not forget this. Let us make use of this. So let us just take LCM. Alpha plus beta equals to 3 by 4. You know that you've just calculated sum of roots and product of roots. Using this, minus R upon minus R square equals to 3 by 4. So R is coming out as 4 by 3. Okay, R you have got. Now you have got R, that means you have got the whole quadratic equation, right? So if you have quadratic equation, you can have alpha and beta also, right? So your quadratic equation will become what? X square. Okay, rather than quadratic equation, let just tell me one thing, alpha minus beta whole square. What is that? Ma'am, alpha plus beta whole square minus 4 alpha beta, correct or not? Right? Alpha plus beta whole square will be R square minus, sorry, it will be plus, correct? So it is R square plus 4 times alpha beta, that is R square. So 5R square basically will be your answer. 5R square will be 5 into 16 by 9, correct? So this is going to be 80 by 9, that is option A is absolutely right. Clear? Any doubts? Any confusion? Do let me know in the chat box, okay? And then we are having a question from Newton's method, and that is also a modified version of Newton's formula. Let me just tell you what is a Newton's method or Newton's method for quadratic equation says. Now you must be wondering, Newton is already everywhere in physics and in mathematics also. Yes, definitely. So Newton's method says that if you have a quadratic equation ax square plus bx plus c, and if you have an expression Sn, expression of the type Sn equals to p alpha raised to power n plus minus q beta raised to power n. This is a generalized version. This is your Sn. Then if this is the expression, then your quadratic, with the help of quadratic equation, you can write a relation between A, B and C and your Sn also. Let me tell you. So the condition of Newton formula I'm going to write over here, A, B, C, correct? X square will be replaced by Sn. X will be replaced by Sn minus 1, and this 1 will be replaced by Sn minus 2. That's it. This is your Newton's method, okay? Now, obviously, it is very easy to identify. Can you see that as per the question, this is our expression, 2023 alpha raised to power n plus 2024 beta raised to power n. And this is your quadratic. So, x square will be replaced by Sn. Then x will be replaced by Sn minus 1. Coefficient will be copied. Minus Sn minus 2 equals to 0. Now, can you just see and look at the options over here. Option suggests that n should be equals to 12. Then we will get a relation between S12, S10, S11. S12 will be equals to S11 plus S10, same thing. So S12 will be S11 plus S10. Clearly option B is absolutely right. Okay. Clear? All right. Now we are moving towards the another question. Okay. Another question says that set C is having ordered pair x comma y in such a way that it satisfied, both x comma y satisfies this relation, x and y both are natural number. X square minus 2 raised to power y equals to 2023. Correct? Now, let me just modify this. Can I just take 2 raised to power y on the right hand side? Now I need to think. So basically, I want to make this as a perfect square. That's what I want. Correct or not? So what I'll be doing is, I will start writing y equal to 1 because natural number, no, very beginning. Let's start with the very beginning. Y equal to 1, let's see what happens. Okay. So the moment I write y equals to 1, it will become 2023 plus 2. So x square will be what? Tell me. 2025. Now just tell me. 2025. Do you know? You can calculate root as well. If you calculate 45 square is actually 2025. So that means 45 comma 1 is one such square root. Okay. 45 comma 1 is one such square root. Okay. So now another, if you try y is equals to 2, y is equals to 3, y is equals to 4, you will realize that apart from this ordered pair, you're not getting any other ordered pair, right? So only ordered pair which will sit inside set C is 45 comma 1. Now what do you want? Sum of all the values of x plus y. So different set of x and y. So just add it. So I am getting only one. 45 plus 1 will be equals to 46. 46 is the right answer. Okay. All right. Okay. So easy question, I guess, but yeah, a little bit tricky one because you have to think a lot in this. Alpha comma beta, next question, belongs to natural number. Be the roots of x square minus 70x plus lambda, where lambda by 2 and lambda by 3 doesn't belong to natural number. Hold on. Alpha and beta are natural number. Be the roots of x square minus 70x plus lambda. X square minus 70x plus lambda equals to 0. Alpha and beta are roots. Both roots are natural number. That's the first thing. And lambda over here is in such a way that lambda by 2 and lambda by 3 is not a natural number. What does that mean? That lambda is not at all a multiple of 2 and lambda is not at all a multiple of 3. And lambda will be as minimum as possible as per the question, and we are looking for the value of this. So this means that we need to calculate alpha, we need to calculate beta, we need to calculate lambda. Okay. So what do we know? We know only sum of roots, product root. Quadratic mein we don't know anything. We are like doing only 10th class quadratic. Sum of roots 70, product of roots lambda. Yes, okay. And let us solve these two. Alpha plus alpha into beta, alpha, beta. Beta can be replaced. Just calculate the value of beta from here. 70 minus alpha and put it over here. This is going to be lambda. Okay. Now understand. Understand one thing. Lambda is right hand side is not an even number. Why? Because lambda is not divisible by 2. So lambda, if I start thinking about lambda, what can be the value of lambda possible? Because minimum possible values I am looking for, right? Lambda cannot be lambda, if I talk about lambda now, Lambda, if lambda is 1, then what will happen? Tell me. If lambda is 1, then alpha and 70 minus alpha. So alpha and these two should also be natural number. Alpha cannot at all be 1. Cannot be 1. Lambda cannot be 2 because of this. Lambda cannot be 3. Lambda cannot be 4. Again, even number. Lambda equals to 5. We need to check for this because we are looking for minimum possible. Right? Minimum possible may we only have few options, right? You know? So lambda equals to 5 if I take. So this is alpha. 70 minus alpha equals to 5. Okay. Basically 5k. 5k. Multiple of 5. Okay. So what I'm trying to say is that if lambda is 5k or multiple of 5, minimum possible we are looking. So alpha should also be what? Multiple of 5. Right? Both, we have to balance both the things. Na? Either alpha or 70 minus alpha. It should be multiple of 5. Let us take alpha as 5. Okay. So now alpha. Let's take alpha as 5. If alpha is 5, okay, then 70 minus 5. This is your lambda. 70 minus 5 is 65. So beta is 65. Then what will happen? Lambda will be 65 into 5. 5 5s are 25. 6 5s are 30. 325. Lambda is 325. Right? So the minimum possible value. So now here, this is root alpha minus 1. So root alpha minus 1 is root 4. Plus root beta minus 1 is what? Beta, root beta. 68. Okay. 64, right? This is your 1 bracket. Lambda plus 35. 325 plus 35 upon alpha minus beta. Alpha minus beta is 60. So 2 plus 8, 10. 10 into, it is going to become 330 upon 60. Perfect. Now, 3 2s are, 3 1s are, 55 is the correct answer of this particular question. 55? Sorry, this is 360, right? 6 0 0 cancel, 6 1s are 6. Hold on, this is actually not 55. So this is 6 8 to 10 multiple upon 60. Alpha minus beta is coming out as 60, right? And what about this? This is 360. Perfect. Now 6 cancel. 6 6 the 36. 60 is the correct answer. Yes, 60 is the absolutely right answer of this question. Okay. So yeah, this was again a little bit thoughtful question. So this in January attempt, I feel that there were some questions which you need to think about it for the numbers. Number game, you should think, acha, ki if this is the thing, hit and trial. Equation solving is not the game, right? You have to do some hit and trial. Okay. Let's keep that in mind while giving the mock or JEE Main paper. The number of real solution of this equation. Okay, this is my favorite type. Okay. So observation skills again. Can you see? Equation is having, basically this is one expression, multiply the second expression. Product of expression 1 and expression 2 is becoming 0. What does that mean? Product of two quantity is 0. That means either first one is 0 or second one is 0. Okay. So first one is 0. That means first expression. That means x equals to 0 is one possible solution. Now second expression, you look, understand. This is non-negative, right? This x square is non-negative. Okay. This is also non-negative. This is also non-negative. Modulus is there now. This is also non-negative. This quantity is either positive or 0. When it is positive, then not at all, like if it is positive, then like everything is positive. No, everything is positive, then overall you will have a positive result. It should be 0. Can it be 0? You think about it. So it has to be 0 when each and every term of this expression becomes 0 at the same time, which is not possible. See, x square plus 3 mod x plus 5 mod x minus 1 plus 6 mod x minus 2. Okay. We want this to become 0. Now, this will become 0 when each and every term of this expression becomes 0, but at the same time. It is not possible because this is becoming 0 at x equals to 0. This is becoming 0 again at x equals to 0. But at x equals to 0, these two are not becoming 0. So, at one value of x, this whole expression can never be 0. If you put any other value than this, then it is going to become positive. So, what I am trying to say is expression 2 is always positive. It can never be 0. Negative though, it cannot happen. So, that's why only one solution, that is x equals to 0, is the final solution of this particular question. And now we are having another question. Okay. Another question says that for this 0CBA, so basically they have given A is the largest value, then B, then C, and all the three values are positive. The order is A is highest, B is middle, C is the lowest. Okay, all right, let's keep it in mind. Now, this very big quadratic equation is given to us. Understand, whenever there is some cyclic order is given in the quadratic equation, right? Whenever there is any cyclic equation is given in the quadratic equation, then obviously that you will find one root just by hit and trial. Majority of the time in cyclic order, na, x equals to 1 will satisfy, or x equals to minus 1. That's it. So you put x equals to minus 1, you will realize. If you put x equals to plus 1, put x equals to 1 in this. And whenever you see cyclic order means C. Coefficients are like, coefficient is having some pattern. A plus B minus 2C, B plus C minus 2A, C plus A minus 2B. This is what we call cyclic. The cycle is going on. Put x equals to 1, then you will realize this is going to be A plus B minus 2C plus B plus C minus 2A plus C A minus 2B. Right? So this is minus 2C, C, C, gone. A minus 2A, A, gone. B, B, and B, gone. 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 Right? So, basically, x equals to 1 is one root of this quadratic equation. And now, if I proceed and read the second half of this question, alpha is not equal to 1. Right? So, what they are saying is let this is the quadratic equation and alpha be one of its roots. What they are saying is one root, so we know there is 1. Another root they are saying is alpha. Okay. So basically it has two roots, 1 and alpha. Okay. So x equals to 1. Let me just write x equals to 1. X equals to 1 is one root. And another root will be alpha. It is given in the question. Now then among the two statements, which one is correct? First statement says that alpha, if alpha is belonging to this interval. Okay, let me just take another page. So just tell me product of roots. First of all, product of roots, because one root is alpha and another root is 1. Product of roots is C by A, right? In this case, C by A will be what? C plus A minus 2B. And A plus B minus 2C. Alpha belongs to minus 1 to 0. Alpha belongs to minus 1 to 0, right? So alpha is less than 0 and greater than minus 1. This is the case. Statement 1 says if this is the case, then B cannot be geometric mean of A and C. So right now, I cannot figure out what are they trying to say. Hai na? So let's do one thing. Let's extract some information from this. Minus 1, 0, and what is alpha? C plus A minus 2B upon A plus B minus 2C. This is less than 0 and greater than minus 1. Okay. All right. All right. Yes. So now let us solve this. First of all, this denominator, if you look now, A and B, both are greater than C. Okay, so just let me just do one thing. A plus B minus 2C can be written down as A minus C and B minus C. Just tell me, A is greater than C, that's why this is positive. B is greater than C, that's why this is also positive. So A plus B minus 2C, do you agree or not it is positive? Yes. So if it is positive, then we can cross multiply. Okay. All right, let's cross multiply. So this is going to become, so this denominator is anyway, I will say positive. We know that, already we know that, okay. So let's cross multiply, let's solve this out. So it is going to become minus A minus B plus 2C less than C plus A minus 2B, correct? So this is going to become, okay, C over here, then B minus B, so plus B over here. What about A? So this is 2A. So A is greater than B plus C by 2. That is first thing which I am getting from here. Agree? Okay. From this left inequality. What about the right inequality? Understand this nicely. Huh? Okay. The right inequality, only focus on the right side. This is always positive. Okay. So this has to be negative. The numerator has to be negative. Why? Because if you look at the right hand side, the whole expression is negative. Numerator upon denominator, they are saying negative. We know that denominator is negative. Sorry, denominator is positive. We know that this denominator is positive. So this has to be negative, right? If overall fraction, overall numerator by denominator is negative and we know that below one is positive, then the upper one has to be negative, right? So that means C plus A minus 2B is less than 0. So B is greater than A plus C by 2. So these two things we have obtained. Now let us talk about this. B cannot be geometric mean of A and C. But what we are getting is arithmetic mean between A and C, right? So B is actually greater than arithmetic mean of A and C. Correct? We know that arithmetic mean is always greater than or equals to geometric mean, right? So if B is out of range of arithmetic mean, see B, so B, AM and GM, okay? B is higher value, then comes arithmetic mean, then comes geometric mean, right or wrong? So if B is higher than arithmetic mean, it is way too higher than geometric mean as well. So they cannot be equal. That's why option 1 to is absolutely true. Okay. Now a similar thing is written over here. Alpha belongs to 0 to 1. So again, C plus A minus 2B upon A plus B minus 2C. Now this is lying between greater than 0 and less than 1. Correct? Again, same thing we are going to do in this also. So same thing. If it is greater than 0, we to know that this is positive. What about this? This should also be positive. So B is, if this is positive, now B is less than A plus C by 2. That is first thing. And if you solve the left hand side inequality, then A plus B minus 2C is greater than C plus A minus 2B. Correct? A cancel. Then it is going to become greater than, so 3C and 3B. B is greater than C. Okay. Oops. So this is like not at all. We will talk only about this. Yeah. Now B is less than arithmetic mean. Okay. B is lesser than arithmetic mean. So arithmetic mean is greater than geometric mean. Now this time, what is happening? Arithmetic mean is bigger and then comes B and geometric mean. So there is a possibility this time, because see, both B and geometric mean are lesser. There is a possibility. We are not sure, but there is a possibility that B and geometric mean can be equal as per the stats. Okay. So that means option 2 is also correct. Both 1 and statement number 2 are true, absolutely true. Okay, so this is how it is done, this question. All right. Now we are having next question. Okay, all right. So this is a very easy question. This we have done while solving JEE Main 2024 memory-based paper as well. Let S be the set of positive integral values of A for which this is less than 0 for all values of x belongs to R, then the number of elements in S. Okay. So now we are having a quadratic expression in the denominator, which is known to us, by the way. Let us analyze this. X square minus 8x plus 32. Okay. So discriminant will tell that what is happening, with what is going on in this quadratic. B square 64 minus 4 into 32. Can you see discriminant is coming less than 0 and leading coefficient is positive. Leading coefficient positive, discriminant less than 0. Leading coefficient positive, discriminant less than 0. Oh, all right. What does that mean? That this quadratic expression is always positive no matter what happens with x, no matter what value you put. So this denominator is always positive. That means, again, if numerator by denominator is a negative quantity, see, numerator and denominator is negative, then numerator, right, this numerator should be negative because denominator we know is always positive. The numerator has to be negative, right? Numerator has to be negative. So if numerator has to be negative, any quadratic expression, you want any quadratic expression to become always negative, the only thing is this graph. Okay? Right? Absolutely negative. That means leading coefficient negative and discriminant less than 0. Okay. So that means this A is less than 0. Right? Leading coefficient negative. And can you see that they are asking the positive values of x? So there will be no positive values of x. It is not going to happen. It is not possible. So 0 positive values of x will be there. Okay. All right. Clear? All right. Now let us look at the next question. Okay. The number of solutions of this equation is, so it is very obvious that this is e raised to power sin x and this is e raised to power minus sin x. You know, e raised to power sin x, if I take as t, then e raised to power minus sin x will become 1 upon e raised to power sin x. That is going to be 1 by t. So this whole thing, whole equation now will become what? Tell me. T minus 2 by t equals to 2. This is a normal quadratic equation, right or wrong? So just solve it. T square minus 2 equals to 2t. T square minus 2t minus 2 equals to 0. Correct? Now 2 plus minus square root of 4 plus 4 2s are 8 by 2. This is your t. So t is coming out as 1 plus minus root 3. Correct? So 1 minus root 3 will be negative. And 1 plus root 3 will be 2.73. So basically this is coming out as plus sign if you take 2.73. Minus sign if you take 1 minus 0.73 with a negative sign. Now just tell me, this t can never be negative. Yes or no? E raised to power x is always positive. That means this is not possible. Only thing which can happen over here is e power sin x is 2.73. That also we need to check. By the way, sin x, you know the range of sin x. This sin x can maximum be 1. So the maximum value of the left hand side is e raised to power 1. Now the value of e raised to power sin x is actually becoming 2.73. Now the maximum value will be e raised to power 0 minimum, right? Actually e raised to power minus 1 will be minimum and e raised to power plus 1 will be maximum. So 1 upon e to e raised to power 1. This is the range of the left hand side. 1 by e, so let's talk about e. The value of e is 2.71. So left hand side maximum can become 2.71. But right hand side is what? 2.73. They cannot match. The number of solution is clear cut 0. Okay. All right. Yes. And now another question on our screen. Is this the last question? Okay. We have done actually very quickly we have finished quadratic equations, right? Okay. Let ABC be the length of three sides of triangle satisfying the condition this. Okay, basically this is a quadratic equation. And if the set of all possible, okay, first half we need to decode, then we can proceed with the second half. Let's decode the first half. A square plus B square x square minus 2b a plus c x plus b square plus c square equals to 0. Correct? Okay. Now a square, understand what is happening over here. Because I can see a square, a complete square is getting formed. Ax whole square, bx whole square. A square plus b square minus 2ab. So what we want is minus 2ax bx. ab x square. Hold on. No. Yes. So ax whole square, then b whole square. Now minus 2abx. Correct? So what we have picked, we are clubbing the important terms together. A square, x square. Then minus 2bax. Then only b square. Okay? So this is one thing. Plus, now another left out things. Now bx. bx whole square plus c square minus 2bcx. Okay? Equals to 0. Alright. Ax minus b whole square plus bx minus c whole square equals to 0, right? Now, in here, if you see, okay, two perfect squares. Sum of two perfect square is coming out as 0. Are you able to think? Sum of two perfect square is equals to 0. That simply means that both has to be 0 at the same time. Otherwise, how will they become 0? Otherwise, so any squared quantity is either 0 or positive. So both are positive. So two positive quantity sum can never be 0. Both has to be 0 at the same time. What does that mean? X equals to b by a and x equals to c by b. Okay? Or we can say that ax equals to b, ax equals to b, bx equals to c. Okay? All right? Yes? Okay. bx equals to c. Now, ABC be the length of three sides of a triangle, right? So if ABC are length of three sides of triangle, then we know one relation. Sum of two sides is greater than third sides. Sum of two sides is greater than third side. Sum of two sides is greater than third side. Correct? Okay. So now what we will do is a plus b greater than c. Let's solve this out. A plus b. Now b can be replaced by ax. So a plus b can be replaced by ax. Greater than c can be replaced by bx. Correct? A plus ax greater than now b again can be replaced by ax. What is happening? A to is a positive quantity. You can cancel it. 1 plus x greater than x square minus x minus 1 less than 0. Right? You can solve it out. So it is going to be, if you calculate the two roots, it is going to become 1 plus minus square root of b square plus 4 root 5 upon 2. So 1 minus root 5 by 2 upon 1 plus root 5 by 2. So this is your solution of the first thing. Second thing now. Again, b is what? Ax. Correct. And yes, c is what? C can directly be written as ax square greater than a. Again, a cancel. So x square plus x minus 1 greater than 0. Again, you can calculate. So it is going to become x equals to minus 1 plus minus square root of b square plus 4 by 2. Correct? So x is minus 1 plus minus root 5 by 2 greater than 0. So this is going to be root 5 minus 1 by 2 and minus root 5 minus 1 by 2. This is like that because greater than is there. No? Here less than was there. That's why the wavy curve is becoming like this. Now a plus c greater than a, c is ax square greater than ax. So x square minus x plus 1 greater than 0. Now this has imaginary roots. So the leading coefficient is positive. Okay. And discriminant becomes negative. That means this is always positive. This is always true. So we don't have to solve it. This is automatically true for every x. So this is saying x belongs to R. You put any x, this will get satisfied. So first and second is the only thing we need to take intersection. So minus, now let's take intersection. What are they asking, by the way? Interval they are asking, okay? So 1 plus root 5 by 2, okay? So if I take intersection, no? So let me do one thing. Let me just plot this thing over here. Root 5 minus 1 by 2 will come somewhere over here. And minus root 5 minus 1 will come somewhere over here. Okay? So now, this will be like this. And this will be like this. Correct? So finally, the intersection area will be this area. Root 5 minus 1 by 2 to root. So interval x belongs to final intersected area. Root 5 minus 1 by 2 to root 5 plus 1 by 2. Correct? So alpha is root 5 minus 1 by 2. Okay? Alpha is root 5 minus 1 by 2 and beta is root 5 plus 1 by 2. Let us plug in the value. 12, alpha is root 5 minus 1 by 2 whole square plus beta is root 1 by 2 whole square. Correct? This is going to be 12 by 4. 5 plus 1, 6. 5 plus 1 again 6. And minus, like here minus 2 root 5 will getting created and here plus 2 root 5. Both will get cancelled out. 4 3s are 12. 3 into 12. 12 3s are 36. 36 is the final answer of this question. And with this question, we are done with all the questions of quadratic equations. April and January attempt both. April we already did, right? You can find April attempt also in the playlist. Now, if you're looking for, now 2024 PYQs, so we are doing, and you know the importance of PYQs, right? So 2023 and 2022 PYQs, you can find in Tatva books. Link is already given in the description box. Tatva book is having chapter-wise source of PYQs. Okay. These PYQs are first of all error-free PYQs, and secondly these PYQs are arranged in a manner so as to get like the basics first and then the next level questions secondly, right? Alpha, beta, gamma. So they are arranged like this, chapter-wise source of these PYQs. Error-free solutions, the books are very handy. You can just check out. The link is given in the description box. You can take the books with you in the library also or anywhere in your school also. Okay, so that in case you get time, you can just solve a few questions so that you can finish it off. At least 3 hours questions, so everyone should do. Otherwise, JEE Main is very difficult to crack. Okay. Second thing, you guys are having doubts, ping me on Namrata Jaisinghani, t.me/Namrata Jaisinghani. Okay. And also comment that which video you want next in this PYQ series. I'll be bringing you that video. This is me, Namrata, on this note, signing off.